What if I told you that the biggest tech companies are using advanced math to fix database problems before they even happen? Picture this, a system that doesn't just react to crashes but predicts and solves them like a chess master planning several moves ahead. That's exactly what Stripe is doing with their wild new approach to database management, and it's blowing my mind. Let me break this down for you. When I first read about Stripe's latest engineering feat, I couldn't help but think about how we've been stuck in a loop for years. Every time a database shard goes rogue, teams scramble to fix it with rigid, pre-written scripts. But Stripe realized that approach is like trying to navigate a maze with a blindfold on. It's slow, error-prone, and utterly unsustainable at scale. What makes this really interesting is their decision to model their entire infrastructure as a graph. Think of it as turning their database into a giant, interconnected map where every node is a component, and every edge is a relationship. Suddenly, the problem isn't just about fixing a single shard, it's about finding the optimal path through this dynamic network. Here's where it gets wild. They are using Dijkstra's algorithm, the same one that powers GPS navigation, to prioritize repairs. Instead of blindly following a hard-coded sequence, the system now calculates the cheapest, most efficient way to restore stability. Personally, I think this is a masterstroke. It's like giving your infrastructure a brain that can adapt in real time. But don't take my word for it. Stripe reports a 30% drop in pager alerts, which translates to 200 fewer emergency calls per year. That's not just impressive, it's revolutionary. What many people don't realize is that this isn't just about saving time, it's about saving human lives. Imagine the burnout that's been prevented by reducing those 12 days of unhealthy shard states annually. Let's talk about the old way for a second. Stripe's previous system was a patchwork of plugins and hard-coded logic. It's like trying to build a skyscraper with Legos, fragile, unpredictable, and prone to collapse under pressure. They had to manually intervene for 124 alerts in 6 months alone. That's not just inefficient, it's soul-crushing for engineers. By shifting to state machines and graph traversal, they've created a system that's not just reactive but proactive. From my perspective, this is the future of infrastructure management. It's no longer about writing more runbooks, it's about building systems that can think for themselves. But here's the kicker, this isn't just Stripe's playground. Uber's Odin platform and Meta's AI-driven tools are doing similar things. This feels like the dawn of a new era where automation isn't just a buzzword, it's the backbone of global operations. What this really suggests is that the next big leap in tech isn't going to come from flashy AI models or quantum computing. It's going to come from smarter, more adaptive infrastructure that can handle the chaos of scale without breaking a sweat. And if you take a step back and think about it, this is the ultimate form of software engineering, creating systems that don't just work but anticipate problems before they arise. So the next time you hear about a company automating something, ask yourself, are they just replacing humans with robots, or are they building something that's truly intelligent? Because Stripe's approach isn't just about efficiency, it's about redefining what's possible. What do you think? Is this the future, or are we still decades away from systems that can truly think like humans? Let me know in the comments below.